Hi, in this tutorial, we will have an exercise related to writing resonance structures. So the exercise says that for the following, write all possible resonance structures. Be sure to include formal charges where appropriate. Okay, let's start from the first option, A. So I'm going to draw the base skeletal structure without including any pi bond or lone pairs. And we will decide what may happen. Okay, so we can see that here between carbon and oxygen we have a pi bond, and on oxygen we have a lone pair. So if we write a general structure like let's say X, Y, Z, XY, it has a pi bond and Z has lone pairs. So I'm going to write here X, Y, and Z, and the general formula for this type of resonance structures, X, Y will be sigma bond instead of pi bond, Y, Z will be pi bond instead of a sigma bond, and generally like lone pairs on the Z or negative charge, positive charge will move to X. So that's the general way. So how do we do that? We can maybe erase some parts, and I'm going to rewrite some structure. Okay, so basically I'm going to shift the pi bond between carbon and oxygen by moving this lone pair between carbon and oxygen. Then I'm going to move the pi bond between carbon and oxygen as a lone pair on carbon. So the resulting structure will be, there will be a lone pair on this carbon with a negative charge, and there will be a pi bond between carbon and oxygen, and on oxygen instead of two lone pairs we will have just one lone pair, and there will be a positive formal charge on oxygen. So this is a possible resonance structure. Let's move to next one. Here in the next one we have a pi bond, then a sigma, then a pi bond, and we have a lone pair. So generally we can estimate that the pi bond will move to next sigma bond, and the pi bond between carbon and oxygen will shift as a lone pair to oxygen, and this will be a plausible resonance form. Let's write. So oxygen will be now having just a sigma bond between carbon, and we will have three lone pairs, and there should be a negative formal charge on oxygen. The pi bond now should be here, and what else we can have? So we should have also a positive formal charge on this carbon, so that the net formal charge should be zero. This is again a plausible resonance form. Let's move to the third one. In the third one we have a pi bond, then a sigma bond, and on this carbon we have a positive formal charge. And also we can see that there is here a lone pair on nitrogen. So we can write two resonance form. The first one I am going to show you. So we have a pi bond. This pi bond will shift here, and the positive charge will shift to here actually. So that's going to be the first resonance form. Let's write all the structure again. So the pi bond should move here, and the positive charge should move here. So that's the first resonance form. Then another resonance form we can write from the second structure. I can shift this lone pair on nitrogen to make a pi bond between carbon and nitrogen, because the carbon here has an incomplete octet. It can accept the pi bond. So let's write again. So I'm shifting this one here, and then the resulting structure will be a pi bond here, and H2. And what's going to happen, the nitrogen should have a positive formal charge. Instead of writing in two steps, actually, we can also write in one step, going from the first form to the last form, and I will use a different color for that one. So basically, you can shift first the lone pair on nitrogen as a pi bond, then the second pi bond should shift to the next position, and you can end up the last resonance form just writing adding two arrows. Thank you so much for watching the video.